We can also use our completed unit circle in order to evaluate these trigonometric functions at our special angles. For example, the sine of pi over 3. I know that pi over 3 corresponds to the point 1/2, comma, root 3 over 2. And my sine function wants to know the y value. The sine of pi over 3 is equal to root 3 over 2. For the cosine of pi over 2, I'm going to find pi over 2 in my unit circle, and it corresponds to the point 0, 1. The cosine is asking for the x value of that point on the unit circle, and my x value is 0. To evaluate sine of 5 pi over 6, I will first find 5 pi over 6 on my unit circle, and it corresponds to the point negative root 3 over 2, 1/2. Because the sine function is asking for the y value, this answer will be 1/2. Then to evaluate the tangent of negative pi over 4, I'm going to first find negative pi over 4. Negative pi over 4, remember, is coterminal to 7 pi over 4. We're going to pi over 4 distance in the negative direction. So that's my point. And I need to do y divided by x. I'm going to do my y value, negative root 2 over 2, divided by my x value. Well, that means I will multiply by the reciprocal, so I have the negative root 2 over 2 times 2 over root 2. Then I'll try to cancel some things, like maybe this 2 can cancel here, and I'm going to be left with negative root 2 over root 2. And then I see, oh, I could have done more canceling. The root 2's will cancel out with each other. And when I do that, I'm left with just a negative 1. So my tangent of negative pi over 4 is negative 1. Let's try a few more. To evaluate the secant of negative pi over 3, I'm first going to find negative pi over 3, which is right here, coterminal to 5 pi over 3. The point that it corresponds to is 1/2, comma, negative root 3 over 2. And the secant is 1 over the x value. So this is going to be equal to 1 divided by 1/2. All right, we will multiply by the reciprocal, and we're going to get 2. To find the cotangent of 11 pi over 6, 11 pi over 6 corresponds to the point root 3 over 2, comma, negative 1/2. And the cotangent is the x value divided by my y value. So since I correspond to this point, my answer is going to be my x value divided by my y value. Multiply by the reciprocal. The 2's will cancel out, and I just get negative root 3. Secant of pi, pi corresponds to the point negative 1, comma, 0. And secant is 1 over the x value. 1 divided by negative 1. Well, that's 1 over negative 1, or just negative 1. One last example, the cosecant of 7 pi over 2. First, we need to figure out where 7 pi over 2 is. Again, we can subtract 2 pi from that until we get something that we recognize between 0 and pi over 2. But my favorite way to locate this is to count pi over 2's around the circle. So 1, 2, 3, 4, 5, 6, 7 pi over 2 must be coterminal to 3 pi over 2. That corresponds to the point 0, comma, negative 1. Well, now that we know that, we're going to remember what cosecant asks. Cosecant asks us what is 1 over the y value. So 1 divided by negative 1 is negative 1. So now, using just this completed circle, we can answer questions about all 6 of our trigonometric functions corresponding to any of our special angles, or even angles that are coterminal to any of our special angles. That opens up a world of possibilities. Unfortunately, though, there are still some angles that we're not going to be able to approximate easily by hand until we learn a lot more techniques later in the semester. So until then, we're going to learn how to use the calculator to at least approximate some of the values. For now, let's use the calculator to estimate the sine of pi over 8 and the cosine of pi over 16. Before we go to the calculator, though, let's try to get an estimate of what we think these values might be. To do that, let's first try to estimate where pi over 8 is. I know that pi over 4 is right here, so pi over 8 would be half of that distance, about right here. The sine of pi over 8 would correspond to the y value of this point. And while I can't tell exactly what my y value is, I can at least approximate it. It seems to me like this might be somewhere maybe between 0.1 and 0.3, but I'm not really sure. Then the angle pi over 16 is going to be actually half of the angle of pi over 8, so it's probably about right here. The cosine of pi over 16 would be the x value that corresponds to this point. And it's hard to tell exactly what this is, but my guess is that, well, it seems like it's very, very close to 1. The x value seems like it's probably about 0.9 or maybe 0.95 or maybe even bigger. Now that we have an estimate of what these might be, let's go to the calculator to get a true approximation. A standard calculator has a sine, cosine, and tangent button right here in the middle. And that's what we'll use to be able to evaluate these. Before we use that button though, we have to check what our calculator mode is in. Because we can measure angles in both radians and in degrees, our calculator has both a radian and degree version of our sine, cosine, and tangent buttons. Because I want to evaluate pi over 8 and pi over 16, and those are in radians, I'm going to make sure that my calculator is in radian mode. If later on I wanted to calculate the sine of 15 degrees, for example, I would need to make sure that I'm in degree mode for that. We'll stay in radian right now. I'll hit second, quit to get out of that. And to approximate sine of pi over 8, I'll write sine of pi is the second function on my caret above the division over 8. And that's about 0.38, which is maybe not quite exactly what I had estimated, but it was a very rough estimate. And let's see, what about the cosine of pi over 16? We said that this one would be pretty close to 1, and indeed it is. It's 0.98. Let's record these in our note-taking guide. The sine of pi over 8 is approximately 0.38268. And the cosine is approximately 0.98079. It is very important to use these approximately symbols here rather than using an equal sign, because I did have to round my answer. Sine of pi over 8 is not exactly equal to this number. It is approximately this number. There's a lot more numbers that I didn't write down. We can also use our calculator to evaluate the tangent of negative pi over 4, and that answer is actually -1, and you can confirm that with your calculator right now. This is a time where I'm going to put exactly equals to 1. I'm not going to put approximately, because as you see in your calculator, the decimal doesn't go on forever. The answer is just -1. We can also use the calculator to evaluate cosecants, but we actually don't have quite all the tools that we need for that, so we're going to save this one for later, once we have a few more tools in our hands. We actually could have also used the calculator to get decimal approximations for all of our special angles, but they would have been just approximations. The calculator can't give me √3/2. It can only give me the decimal approximation for it. And in general, we really want the exact answer whenever possible. So on homework or other assessments, when you're asked to evaluate a trig function at one of our special angles, I do want you to give an exact answer, like √2/2, or √3/2, or a half, or whatever the answer is, rather than giving the decimal approximation. Let's save the calculator decimal approximation only for real-life examples when I need to know the exact answers, or when we're trying to evaluate things that are not special angles.